All right, man. I just wanted to make a video on this question over here. An arithmetic series has first term a and common difference of d, where d is a prime number. The sum of the first n terms of the series is Sn, and Sm equals 39, S2m equals 320. Find the value of d and find the value of m. So straight away, I know it's a sequence question. Arithmetic series, sequence, sum. So we're going to be using this equation. So, we know the sum of the first n terms of the series is Sn, and Sm equals 39, and S2m equals 320. Some weird terminology, but all this means is the sum of the first m terms is 39, the sum of the first 2m terms is 320. So we can plug in both these bits of information into this equation. So let's make an equation for the first line. So the sum of the first m terms is 39. So the sum is 39. The number of terms is m terms. 2a, we don't know what the a term is. And the number of terms we're adding is m. D is the difference between the terms, which we don't know. Oh, what did I do? D, which we don't know. And then, let's leave that for there now. Let's do the same thing for this equation here. The sum of the first two m terms is 320, so the sum is 320. And the number of terms is 2m. And then 2, we don't know what the first term is, it's still a. The number of terms we're adding up is 2m. D, we don't know. Can we simplify this a little bit? I guess we can do this. 320, 2m over 2 is just m. 2a plus 2m minus 1d. Yikes. Still, there's not much we can do here. Why don't we expand the brackets and simplify a bit more? Well, here, first things we can do is we can get rid of this divide by 2 by timesing both sides by 2. So we can say 78 equals m 2a plus m minus 1d. Still, we have this and this. Not really helping us here. Let's expand the brackets, why not? So 78 equals m 2a, m times d is md, negative 1 times d is negative d, and we'll expand this even more. M times 2a is 2am, plus m times md is m squared d, m times d is dm, or md, whatever you want. Same thing here, so 320 equals let's expand these brackets first. 2a plus 2md minus d. 320 equals 2am plus 2m times 2md is 2m squared d. M times d is md. So we have this and this now. Ah, shoot, still, it's kind of hard to spot this part, but what we can do is we notice that we have 2am, 2m squared d, m squared d, kind of close, and then md and dm, same thing. Let's just reverse, let's make md dm, so it's just, we're on the same page. So we have minus dm. What if we were to subtract the equation? So we have 320, we'll do this equation on top, equals 2am plus 2m squared d minus dm. This equation on the bottom, 78 equals 2am plus m squared d minus dm. What if we were to subtract the equations? This is the hard part to spot. We can subtract these equations. It's kind of like a simultaneous equation. So 320 minus 78. 242. 2am minus 2am is nothing. 2m squared d minus m squared d is just 1m squared d. And then minus dm minus dm. This could be tricky. Minus dm minus dm. Minus makes plus, so minus dm plus dm is nothing. So we're just left with this. And then it says Let's read the question. An arithmetic series has the first term a and common difference of d, where d is a prime number. So the values of d are quite limited. So let's just plug in some prime numbers, and then hopefully we can find our m value. And m is the number of terms we're adding, so m must be a whole number. So first, let's think of some prime numbers. Well, the first prime number is 2. So let's say d is 2. And we can find m. So 242 equals m squared 2. We'll divide both sides by 2. 121 equals m squared. So m must be 11. And that's our answer. D is 2, m is 11.